All right, so welcome to Phidgets Getting Started webinar. We're going to be using our Getting Started kit today, as well as Java with NetBeans. So there are a number of different development environments you can be using with Java and Phidgets. Today we're going to be using NetBeans. So to start off, you'll want to navigate to phidgets.com/education. So this is the main page of the Phidgets education website. This is really where all the education stuff lives, any product information, all the courses, everything lives in this website. Currently, Phidgets is targeted for students in grade 9 to 12 with coding experience. It's not necessarily for the most novice coder, but you don't have to be overly experienced as well. As long as your students know loops and conditionals, so your if statements, they're good to go with Phidgets. So as I mentioned before, we are going to be focusing on the Getting Started kit today. So that's got the humidity fidget, the 2 buttons and the 2 LEDs. So to get started, you'll want to navigate to this Learn tab. So there's a few options under Learn. There's some general information about what Phidgets are. This is a great tool for students just to learn about what they're learning about, so they aren't just being presented with a tool that they don't understand. The great thing about Phidgets is it is a real world tool. So professionals use this throughout the world in their research and in industry. So it's a really practical tool for students to be learning, and that's a great place for students just to begin to understand what Phidgets are. We have the Getting Started kit. So that's the Getting Started kit and course. So that's your fundamentals of Phidgets. So it's a really big jumping off point. If students haven't done this, they might struggle with the later projects. So really the Getting Started kit is your core of Phidgets programming, although it doesn't stop there. Then we have device tutorials. So Phidgets are made up of a number of devices, things like your thumbstick fidget, your sonar fidget, which measures distance, your spatial fidget, your light fidget, things like that. So these are individual tutorials to learn how to use those devices. And then we move on to projects. So projects contain more things to do with your Getting Started kit. So again, you're not ending with that course. You're getting multi-purpose out of your kit. The rover kit is also located in projects, as well as each individual sensor does have projects that go along with it. So again, you're getting lots of use out of your product. It's not just a singular course or a singular output. But today we're going to be talking about the Getting Started kit. So we'll click on that, let that load. So today we're looking at the Getting Started kit, again with Java and NetBeans. So the Getting Started kit is made up of a few different sections, as well as we've just added an advanced lesson section, which we're really excited about, and we will be going over that today. So if you watched any of the previous webinars, you probably wouldn't have seen the advanced section lessons, so those are newly added. To get started with your Phidgets Getting Started kit, the first thing you'll want to do is set your language and environment. So Phidgets currently are compatible with Windows computers and Mac OS computers. Unfortunately, we do not have Chromebooks yet. Hopefully they'll be coming soon. But today I'm working on a Mac computer. So I've selected Mac. We're going to be reviewing Java, and we're going to be using the NetBeans development environment. Now, if you're using Java, you could also use Eclipse. If you're using Python, you can use Thonny or PyCharm with a Mac. With Windows, you can also use PyScripter. With Windows and Mac, you can use C# and Visual Studios, or Mac, you can use Swift and Xcode. So lots of options for both languages and development environments. So whatever suits your classroom best is a great choice. So once you select your path, you select Done. Now all of the Phidgets website will appear in Java with NetBeans. So students only have to select that once and it will be remembered by the computer. You can tell what language a student selected up here in the top right-hand corner. So that's a great first troubleshooting section. If students get stuck, check to make sure that they have the correct language selected. Now today I'm not going to review the build kit, but the instructions are there. They're step-by-step with pictures to assemble your getting started kit. However, I will review configure. So when we click on configure, the first thing we'll see is this Hey Mac users. So if you're using a Mac computer, you will have to install the Phidgets libraries before you get started. If you are using a Windows computer, you do not need to install the libraries. You do not need to install anything. So that's the major difference between using a Windows computer and using a Mac computer. Other than that, the instructions are pretty much the same on both streams. If you want to check out the Windows instructions, the previous Getting Started with Java tutorial did review the Windows instructions. So if you want to check back on that one, it'll give you the step-by-step. So after we've installed all the libraries, the first thing you'll want to do is download this Phidgets Java folder. So we download this folder. And then in our downloads, we'll double click to unzip. There we go. And then we can delete this zip folder. So you'll see phidget22.jar. So this is your main file you'll want to be using to configure Phidgets with Java. Leave that for now. Next, we'll want to open NetBeans. So if you're unfamiliar with NetBeans, you can download NetBeans for free at netbeans.org. There's a download here. It's a great environment for Java. We really enjoy it. So the first thing you'll want to do when you open NetBeans is create a new project. You'll want to select Java with Ant, and then Java application. Then click Next. You'll name this project Getting Started. Getting started, and then you can choose your project location, and I'm just going to use the default one for now. And select Finish. All right, so when that project is made, you want to go over to this sidebar here and open that project. You'll want to right-click on Libraries and add jar folder. Next, you'll want to navigate to that Downloads folder and find that file that we just downloaded on our computer. Then select Choose. And you will see the Phidgets22.jar now under your libraries. And that's it. Now we're ready to move on. That's our configuration with NetBeans. So it's a really simple way to just get started, not too complicated, just adding that file to gain access to those Phidgets libraries. Now we select Finish. All right, and with that, we'll move on to our first set of lessons. So we've divided the lessons into two parts, Simple Phidgets and Smart Phidgets. So your Simple Phidgets are your buttons, your two buttons, and your two LEDs. Your Smart Phidget will be that humidity fidget that's attached to the back of your box. So a lot of Phidgets you encounter will be a Smart Phidget, and some of them will be Simple Phidgets, and we'll see the difference as we go through the code. So let's check out this blink LED lesson. So all of our lessons are formatted the same way. The first thing is an image or a GIF showing students what to expect in this lesson. So in this case, we're learning how to blink an LED. So we have a GIF showing the LED blinking. The next section will always be a code sample. So the code sample is a runnable sample that will basically give you the output that's shown in the GIF. So get students interacting with their devices and interacting with code quickly. The next section is a practice section. So this section's really designed to get students engaged in reading and understanding that code. We're not just giving students free code, they have to actually read and look into it. You'll notice, also notice that there is a troubleshooting section. So the goal of taking advantage of an online platform is trying to get students as independent as possible so they can work through this at their own pace, and giving students some freedom to do the basic troubleshooting. So things like checking to make sure Phidgets are plugged in, that you're not running another program, and some basic troubleshooting steps. So let's check out this code. So we copy the code with this little button up here, and then we paste it in. Now get everyone to look up at my corner of my screen because this happens fairly fast. So I'm going to run my code. And my LED turns on and off. I'll do that again. So it turns on and off. So that's the first thing students will see, is that LED blinking on and off. So let's take a deeper dive into this code. You'll notice when I copied and pasted the code into my NetBeans, there's this additional description that appears in the code. So students can access that also by rolling over these comments in the code. So each comment will explain what's happening in the code below, outlining the basic format of a Phidgets program. So the first thing every Phidgets program needs is to import the Phidgets library. So that gives us the code access to all of those Phidget library goodies so you can actually talk to your Phidget. In Java, we do have to throw an exception. Then the next thing we need to do is create a software representation of that physical Phidget. So in this case, the LED uses a digital output object. So we create a new digital output object for that red LED. The next thing we're going to want to do is we're going to want to address our Phidget. So we've created that software object. Now we want to tell our program where to find that Phidget. So this is where you set your hub port, and you set hub port device to true for simple Phidgets. So you'll notice if you look closely at your Vint hub, or if you remember from your assembly, the hub port or the Vint hub has a number of ports on it that are numbered. So in your addressing section, you're really just telling which port the Phidget is plugged into. So we've created our representation of our physical Phidget. We've told our program where to find our physical Phidget. Now we need to tell our program to start communicating to that Phidget. So that's when we use the open call. So we open our Phidgets, open that communication pathway, and then we wait for 1 second just to give the computer some time to form that connection. If we leave that out, we will get errors when we start to try to use our Phidget because it's not quite communicating yet. Next, we are going to use our Phidget. So this is where we turn our LED on and off. So we set the state to true to turn our LED on. We sleep for 1 second to keep our LED on for that 1 second. So that sleep timer is just keeping that LED on, and then we're turning that LED off with setting the state to false. So students will explore this code, things like learning about the sleep timer, learning what turns the LED on and off, and learning about that address section. So the address section is really key, learning that it's not the variable name that decides which fidget you're interacting with, but in fact it is that setting hub port that is telling you which fidget you're interacting with. So again, students get into the code quickly, they get into that practice, and the practice really gives you, as a teacher, a checkpoint to see how students are doing, how students are understanding, as well as some assessment opportunities. So then we move on to lesson 2. So again, we have that GIF showing our students what to expect. We have that code sample, and we have our practice. So let's take a look at this code sample. Again, we copy it in, and we paste it over top of our old code. Now we run our program. So now if we take a look at our console here, you'll see button state false being printed to the console. So that's because I'm not pressing the button. Notice when I press the button, the output changes to true. When I release, it changes back to false. So we're reading in that button input. Now, in this case, we will want to stop our program before we move on. With continuously running programs, we do want to always make sure our students and we are stopping our program before we move on. If you try to run another program while a fidget is being used by another program, you'll get errors and it will cause a lot of confusion. So just make sure it's good practice always to stop that program before you move away. So let's take a look at that code again. Again, we're adding that Phidgets library, bringing in all of that good fidget stuff into our program. We're handling exceptions. Then we are creating an object. So for a button, we use a digital input object. So we're creating that software representation of our physical fidget. We are telling our software object where to find our fidget. So setting the hub port to 0, that's where our red button is plugged into, and setting that hub port device to true because it is a simple fidget. Next, we need to open our fidget. So we use this open call. Again, we let it sit for 1 second just to give it that time to have that communication path formed. Then we use our fidgets. So in this case, we use an approach called polling. So it's an infinite while loop that continuously checks the state of the button. Now we do have the sleep timer in here just to manage the output. So every 150 milliseconds, the button will be checked and the state will be outputted. So students explore this sleep time and this polling approach in their practice, as well as exploring that address section as well. Lastly, lesson 2, question 3 is a really important question going forward. We really want to highlight that for students. It's modify your codes so to only print the button state when the button changes. So it involves a Boolean variable and an if statement. And you really want to make sure students get this question before they move on because it is used throughout the program. Then we have, again, a troubleshooting section to go through the major issues that students may encounter. Then we move on to lesson 3. So this is where you use your buttons and your LEDs together. So when you press the button, the LED will turn on. When you release, the LED will turn off. So I'm not going to demo the code this time. However, I will review the code. So again, we're adding that library. We're handling those exceptions. We're creating an object for each one of our devices. So each device needs its own object. Next, we are addressing each one of our devices. So the red button, the green button, the red LED, the green LED all need to be addressed. We need to tell our program where we're finding these objects and these fidgets. Next, we're opening each one of our devices individually with that individual wait time, just to give time for the fidgets to communicate with the computer. Next, we're using a polling method once again, that infinite loop with that sleep timer. We are checking the state of the button and turning on the LED according to the state. So when the red button state is true, we will turn that LED on by setting the state to true. Same with the green button. Once again, we are exploring the code through the use of these rollover comments and the practice questions. Again, that use of that last question that I highlighted, that lesson 2 question 3, it comes back into play again in this question here, where you count the total number of button presses. So how many times the button is pressed. You use that code from lesson 2 practice question 3. That's why it's such an important question. We also learned that the colors do not mean that the devices are connected. The fact that everything is controlled through your code is also highlighted in this section. Next, we have a practice project. So building a tug of war game. This is really great for students. It gets them engaged in the code and problem solving, taking all of those little bits and pieces that they've learned and putting them all together to form a new section. It's also great for you as an assessment opportunity and as a checkpoint for students before they move on. It's also a fun little game to play. And with that, Simple Phidgets is complete. So students should now know how to use their LEDs and their buttons. Next, we move on to Smart Phidgets. So Smart Phidgets, again, is that humidity fidget that'll be attached to the back of your box. Once again, we have that GIF showing the use of the fidget. With the temperature fidget, you can hold it to change the temperature. You can also blow on it. Right now, we're recommending holding versus blowing on it. Next, we have our code sample. So you'll notice something different about this code if you look closely. Between create and open, there is no address section. So this is the major difference between a simple fidget and a smart fidget. A smart fidget, most of the time, does not require you to address it. It will tell the program where it is located on the Vin tab. So you do not need to address smart fidgets in most cases. So in this case, it makes our program a lot simpler, a lot cleaner. We just create our temperature sensor object. We open our temperature sensor, and then we use our temperature sensor with that polling approach using the get temperature. So let me explain where that addressing section went and what the difference between the smart and the simple fidget object or simple fidget is here below. Again, we have those rollover explanations. And then we have a practice question again to get students engaged in that code, changing the data from Celsius to Fahrenheit, useful for anyone in the US whose students might be more familiar with a Fahrenheit unit versus a Celsius unit. Again, we have the troubleshooting. So our next section is reading the temperature and humidity from our humidity sensor. So some fidgets will have more than one sensor and more than one item you can interact with on them. So the humidity sensor has both the humidity fidget has both the humidity sensor and a temperature sensor in it. So in the code, we see that as two separate objects. So 2 objects to 1 fidget. A fidget can have many, many objects associated with it. It's not a 1-to-1 ratio all the time. Again, that's explained down here. We will take a look at this section of code. So let's copy it and paste it into our NetBeans. And let's run our program. So in the console, you'll begin to see the humidity and temperature output. So again, I'm in a very warm room today. So you can see the humidity is around 30%, 28, 27, the temperature is around 28 degrees. When I hold my fidget, you'll notice the temperature and humidity shoot way up. So it's a great way for students to test to see how their code works, how it responds, how that humidity sensor works with a really quick manipulation. Again, we stop our code before we continue. So again, we create the two objects, we open the two objects, and then we use that polling method to pull data from our humidity sensor. Once again, we have a practice section. This section goes into more practicing how you interact with the data from your Phidget, looking at what the printing different things depending on what the humidity and the temperature is, just getting that if statement practice in and seeing how to interact with that data. Again, a troubleshooting section. Next, we have a practice activity. So this is another great check-in just to see how students are doing. And again, getting students an opportunity to be a bit more creative, a bit more active, and pulling in, again, all of those things they've learned into one big project. So in this case, they're making a hot or cold indicator. So we're bringing in all that knowledge we have from the LEDs from the first 3 lessons into this project to be used with the humidity fidget. So again, stealing code that we've already written in past assignments, like in the last lesson, we use those if statements to check temperature ranges. So we use that to turn on our green LED or our red LED. And with that, all the basic lessons of Phidgets are complete. So students have learned about all 5 elements, really 6 elements if we include the vent hub, through these lessons. So we really wanted to get students into code, into practice, getting students engaged really quickly with this project and get students creative as fast as possible. So the final challenge of our Getting Started kit is building a thermostat. So that pulls in all of that code they've done from all of the previous lessons. So things like counting the button presses is used to count or to change the temperature of your thermostat. Using those LEDs to tell you whether you're in a comfortable range or an uncomfortable range, whether the heat is on and off, printing that temperature to the user. So lots of different applications for all of those bits and pieces that they've done before, pulling those all together for a great assessment opportunity as well as a great practical practice for students. And once they're done that challenge, the basic Getting Started kit lessons are complete. So students, again, know how to use all 6 devices now and are ready to go either to move on to the device tutorials and projects or move on to these advanced lessons. We will move on to those advanced lessons. So these are the new addition to Phidgets. We're really excited to be having a more advanced lesson section. So this is really great if you want students to dive deeper into Phidgets. If you're teaching Phidgets at multiple level, maybe first year they do the basic course, second year they can do the advanced lessons. If students have knowledge of methods, they'll really enjoy these advanced lessons. Or if you just want a simple bonus activity, or if your students are really into gaming, great lessons to add in. So the first lesson in the advanced lessons is learning how to control your LED brightness. So there's a feature called Duty Cycle, which students can control how bright their LED is. So this is a great simple advanced lesson. So if you just want a simple bonus lesson to add on at the end of your Phidgets, this is a great opportunity. It doesn't require any sophisticated code. It's simply just changing that brightness by adding set duty cycle instead of a set state. Again, duty cycle will change the brightness. It's all explained in this lesson, again, with some practice. The next set of lessons is events. So if you remember, I mentioned the polling method that we were using in those basic lessons. So this is an alternative to that polling method. So if we take a look at the first event lesson. So this is looking at your button. So instead of using polling, you can use events for your button. Let's copy and paste this code in. So if we run this code with events, the first thing you'll notice is we've only pressed or printed state once. When I press the button, the state true is only printed once. So if you remember that polling method, we had that continuous flow of data, and it was a challenge to get that data to look something like this. So events is a simple way to check your state. Stop me, we'll take a look at this code. So the event here is a state change event. So it's a state change listener we've added. So this code basically listens to your button to see when the state changes. So it'll only run that code that's contained in this when the state changes. So in this case, we add our Phidgets library, same as we did before. We handle exceptions, the same as we did before. We create an address, the same as we did in those simple Phidgets lessons. However, before we open, we add this event. And again, the code contained will run when the button state changes. Then we open, and we keep this while loop here just to keep our program running. So again, we explain what events are here so students can get an understanding of what they're looking at. Then we have some practice questions to compare the code to that previous lesson that looked at buttons, so that lesson 2. So students can see what the difference is and how that code affects the output of the program. Next, we're modifying that loop time just to see how that behavior changes or doesn't change, to get students thinking differently and understanding how the code works in comparison to that lesson 2. Then we go into manipulating what the code actually does, changing the output, and adding in that green button. So again, creating another event for that green button. The next advanced event lesson is using your button and your LED. So in this case, we use our button events to turn on and off our LED. So in our button events, we record our state of our LEDs, and then we use that in our while loop to turn on and off the LED. Again, we have that that practice just to get students engaged in that code. Our smart Phidgets also have events, so there are temperature and humidity change events. So that is the next lesson which we review. Then we move on to attach and detach events. So every Phidget, in fact, has an attach and detach event. So this is related to that connection between the computer and your Phidgets. So let's run this code. So when you run this code, you'll see attached and then the temperature being printed. then if I unplug my humidity fidget, you'll see it detached instead of an error. So the attach and detach event is a great error handling if you have fidgets that may become attached or detached. So every fidget has an attach and detach event. Again, it's a great way to monitor whether a fidget is connected or disconnected. Again, we do that with a attach listener and a detach listener. Again, we can explore that in our code. We have an explanation and a bit of practice, again, giving you an assessment opportunity, getting students engaged in that code. Lastly, in events, we have a data interval. So if you remember from that polling, we used a sleep time to manage how much data we were getting from the fidget. In this case, a data interval controls how often we are checking for an event. So for example, in a temperature event here, we set the data interval. So every 1 second we say, what's the temperature? So we check what the temperature is. If it's different than last time, then we'll print the temperature again. If it's not, then we won't. So this is just controlling how much data we're actually collecting from that fidget and how often we're checking that fidget. Again, we have practice. So those are your event lessons. Again, they're great for gaming and for students who are looking for a bit more of a sophisticated look at fidgets. This would be more what industry would use as far as coding style. Lastly, we have an advanced addressing section. So if you remember, I said smart fidgets you don't need to address most of the time. So if we're using 2 or more of the same smart fidgets or 2 of the same, more of the same software objects, so example, if we're using 2 temperature sensors, in that case, we do need to address our fidget to tell our program which temperature sensor we are talking to. If we don't address them, then we'll get some pretty funky results. So that's great for students looking to start building larger projects and combining kits. As well, we have an advanced addressing for using 2 or more VinTubs. So if a student, for example, wants to use 2 getting started kits, one for a game, each one being an individual controller, they'll have to complete this 2 or more VinTubs lessons. Basically what happens is we add another line in addressing where we set the serial number for our VinTubs, or serial numbers listed on the back of the VinTub. So we just need to set the serial number for each device so then we know which VinTub we're actually talking to. So using 2 or more VinTubs is actually very common in industry. Issue here. For example, here we have multiple fidgets connected using multiple VinTubs. So if we're using more than 6 fidgets, like we are in this case, you will want to use more than 1 VinTub. So this is a really great practical application for students going forward. Again, this is from test view, using 4 VinTubs connected to multiple sensors to monitor their application. So again, getting that more real world connection once again. So with that, that's all of our advanced lessons. Students will understand a bit more depth and get a bit more functionality out of their fidgets using these events and exploring the different applications that can come with events. So with that, the Getting Started Kit tutorial is complete. So if you're looking to get more out of your Getting Started Kit, you can explore projects. So projects does have extensions onto the Getting Started Kit, both more applications of the humidity sensor as well as more applications for your buttons and LEDs. So things like a Simon Says game, a whack-a-mole game, a stopwatch, and just some more fun activities just to get more out of your Getting Started Kit. You can also reuse the Vint Hub with the device tutorials and projects from your Getting Started kit. So you're really getting a lot of use out of a single product. If you're interested in some more educator resources, we do recommend you go to this Educators tab here. If you're interested in viewing this webinar or signing up for future webinars, as well as seeing any past newsletters, we do recommend you go to the News tab. All of our webinars and all the recordings and all the old newsletters are all up on the News tab. If you're interested in purchasing a Phidget, we do have all of the education Phidgets listed under the Buy tab. So you'll find the Getting Started kit, the Rover kit, and all the Phidgets devices. Now, if you're looking for a device that isn't listed on this education page, you can go to phidgets.com and check out all of the sensors listed at phidgets.com. So educators do get a 40% discount off of any Phidget. So if there is something else you are looking to add to your classroom, you can find them at phidgets.com. However, all of the supported education devices, so those with a tutorial or project associated with them, are listed on this education website. With that, we do have a webinar coming up next week. So if you're interested in advanced sensors, so exploring all these devices, I do recommend you check that out. All right, then with that, thanks for coming to this Phidgets webinar, exploring the Getting Started kit with Java. If you have any other questions after this webinar is over, please feel free to email us at education@phidgets.com or follow us on Twitter. We post some projects there, some upcoming events, and different additions to our website there.